For thousands of years, the Milky Way has stretched across the night sky as a glowing river of stars. Ancient civilizations looked up at it and imagined myths, gods, and celestial paths guiding travelers across the heavens. Today we know that the Milky Way is not simply a band of light, but an enormous galaxy containing hundreds of billions of stars, vast clouds of gas and dust, mysterious dark matter, and a supermassive black hole at its center. Our sun is only one small star located in a quiet spiral arm about 27,000 light-years from the galactic center. From our position inside the Milky Way, the galaxy feels permanent and stable. But in reality, galaxies are not eternal. They evolve, collide, transform, and eventually disappear. The Milky Way itself is slowly moving through space, pulled by the gravitational forces of nearby galaxies and massive clusters scattered across the universe. One of the most important objects influencing the future of our galaxy is the Andromeda Galaxy, the nearest large spiral galaxy to the Milky Way. Located about 2.5 million light-years away, Andromeda looks peaceful when viewed through telescopes, but appearances are misleading. Astronomers have measured its motion carefully and discovered something remarkable. Andromeda is moving toward us. The two galaxies are on a collision course. At first, this might sound like a catastrophic disaster, but galactic collisions are very different from collisions between solid objects. Galaxies are mostly empty space. Even though each galaxy contains hundreds of billions of stars, the distance between those stars is so enormous that direct stellar collisions are extremely unlikely. When the Milky Way and Andromeda finally meet, the stars will mostly pass by one another without touching, but gravity will reshape both galaxies dramatically. Long tidal streams of stars will stretch across space. Spiral arms will be torn apart, and giant clouds of gas will collapse to form new generations of stars. The entire process will take billions of years, unfolding slowly on cosmic timescales. Astronomers estimate that the first close encounter between the Milky Way and Andromeda will occur in about 4 billion years. At that time, the night sky as seen from Earth would look completely different. The Andromeda Galaxy would grow larger and larger in the sky over millions of years until it filled a huge portion of the heavens. Eventually, the two galaxies would pass through each other, their gravitational forces pulling stars into long arcs and streams across intergalactic space. After several passes, the two galaxies would merge into a single massive system, sometimes called Milkomeda. The familiar spiral shape of our galaxy would disappear, replaced by a much larger elliptical galaxy formed from the combined stars of both systems. During this enormous transformation, the central black holes of both galaxies would slowly move toward each other. Each galaxy contains a supermassive black hole millions of times more massive than the Sun. As the galaxies merge, these black holes would eventually form a binary system, orbiting each other while emitting powerful gravitational waves that ripple through space itself. Over time, the two black holes would spiral closer together until they finally merge into a single, even larger black hole at the center of a new galaxy. The energy released during that event would be enormous, briefly producing one of the most powerful signals in the universe. But the merger with Andromeda is only one chapter in the long story of the Milky Way's fate. Even after the galaxies combine, the universe itself will continue evolving in ways that slowly transform everything. Over billions of years, the rate of star formation in the merged galaxy will gradually decline. The giant clouds of gas needed to form new stars will become depleted as existing stars consume the remaining fuel. Without fresh gas, the galaxy will slowly transition into a quieter phase of its life. Bright blue stars will burn out and disappear, leaving behind longer-lived red stars that glow more softly. The galaxy will age. Eventually, most of the remaining stars will be small red dwarfs, faint and stable objects that can shine for trillions of years. But even these stars will not last forever. Over unimaginable timescales far beyond the current age of the universe, red dwarfs will also exhaust their fuel and fade away. The night sky of the far future will become darker as fewer and fewer stars remain. Meanwhile, gravitational interactions between stars will slowly change the structure of the galaxy. Occasionally, stars passing near each other will exchange energy, sending some stars toward the center, while others are flung outward into intergalactic space. Over trillions of years, this process will cause many stars to escape the galaxy entirely, drifting alone to the darkness of the expanding universe. The galaxy will gradually lose mass as more stars escape its gravitational pull. Even the supermassive black hole at the center will continue evolving. Black holes slowly grow by absorbing nearby matter, but they also emit an incredibly tiny amount of radiation through a process predicted by quantum physics known as Hawking radiation. Over extremely long timescales, far longer than the current age of the universe, even black holes will begin to lose mass through this process. A supermassive black hole could take around 100 trillion years to completely evaporate. When that finally happens, the last great relic of the galaxy's past will vanish in a faint burst of radiation. By that time, the universe itself will look very different from today. Cosmic expansion driven by dark energy is gradually pushing galaxies farther apart. In the distant future, galaxies outside our local group will move so far away that their light will never reach us again. The observable universe will shrink dramatically from the perspective of any surviving observers. Only the remnants of the Milky Way and Andromeda merger will remain visible, isolated in a vast ocean of darkness. Eventually, the stars themselves will disappear. The galaxy will become a quiet collection of stellar remnants, white dwarfs, neutron stars, and black holes slowly drifting through space. Over unimaginable spans of time, even these objects will gradually disappear through decay or evaporation. The once magnificent Milky Way, home to hundreds of billions of stars and countless planets, will slowly fade into cosmic history. Yet, in another sense, this long future tells a remarkable story about the universe. Everything we see today, every star in the sky, every galaxy glowing in distant space, is only part of a temporary chapter in cosmic evolution. The universe is constantly changing on scales far beyond human lifetimes. And somewhere in that immense timeline, our galaxy's brilliant spiral structure, the glowing band of the Milky Way across the night sky, will one day become only a memory written into the history of the cosmos.